Lab 1. Determining excess charge. The goal for this lab is to understand charge and how excess charge is present on everyday objects. Through this presentation, I will discuss the fundamental properties present in the lab, how charged objects interact with each other, and experiment to determine the number of excess or deficient electrons in an object, and a computer model to depict forces present. Electric charge is the physical property of matter. It experiences a force when placed in an electromagnetic field. There are positive charges and negative charges. The same type of charge will repel each other, while different types of charges will attract each other. Even in regular actions, objects can acquire excess positive or negative charge. Another principal use is the gravitational force. This lab looks to determine the amount of excess charge on an item. We will conduct an experiment to understand how ordinary objects acquire a charge and how they interact with their environment. First, I prepared a charged piece of tape. To do so, I laid the first piece of tape on the table and another piece of tape on top. Quickly rip off the top piece of tape, and if done properly, there should be an attraction between your hand and the tape. Make sure to handle the charged tape as little as possible to prevent the charge from dispelling. Then I created another charged tape. The two objects repel each other. At the moment, I wasn't sure what type of charge they were, but I knew that they were the same type. To find out the type of charge, I placed a negatively charged object near the tape. Since the tape was attracted to the negative object, I now know that the charged tape was positive. This is important because that means the tape will have a deficiency of electrons. If electrons hypothetically had a positive charge, there would need to be an excess of electrons for the tape to still have an overall positive charge. Now we can conduct an experiment to determine the excess amount of charge using two pieces of tape as shown in the diagram below. Before charged tape A is introduced, charged tape B is being pulled down from the gravitational force. After tape A is introduced, tape B begins to float because of the electric force. Since the momentum of tape B isn't changing, the magnitude of the gravitational and electric force are equal to each other. To determine the force of gravity on tape B, I need to know its mass. Setting the gravitational force equal to the electric force, I also need to find the distance between tapes when the forces are equal and the tape first begins floating. This will let me solve for the charge of the tape, which I can then divide by the charge for an electron to find the number of deficient electrons. This was the data I collected over the course of my experiment. The length of tape B was 0.21 meters. The mass of tape B was 0.00021 kilograms. The distance between tape B and tape A when tape B began to float was 0.02 meters. The magnitude of gravitational force was 0.002 newtons. Since the magnitude of electric force is equal to the gravitational force, its value was also the same. I created a computational model simulating the forces from the experiment. With the two charges experiencing a gravitational force and exerting an electric force on each other, I used this model to determine the approximate amount of charge necessary to float tape B. The tapes were each treated as a single point charge located in the center of the tape and that they had the same amount of charge. The magnitude of the charge on tape B was 9.568 times 10 to the negative 9. So we have approximately 5.973 times 10 to the 10 number of deficient electrons to make tape B positive. Throughout this lab, I have shown how objects can build up excessive electrons and how the electric force has an impact on its surroundings. Thank you.